Well, welcome everybody. Welcome back to those that have attended our other webinar, other installments of our webinar series. We've had 3 other webinars up to this point, and welcome to any new folks joining us for the first time. My name is Steve Gregg. I am the president-elect of the Atlanta National Weather Association and American Meteorological Society local chapter. President-elect means basically I am vice president and will take over president duties for next year. Just a reminder for people that have joined the webinar before and also for our new attendees, we launched this webinar series this summer to share scientific knowledge and also keep our chapter connected to the weather community in some way. It's been obviously a big change for everybody's work life and personal life and home life to not be able to meet in person with each other. And so we hope that you all find these webinars useful and provide some interesting information from various members of the weather enterprise. We are joined today by our current president-elect. Sid is a meteorologist at the National Weather Service Forecast Office in Peachtree City, just south of Atlanta. He's been at that office for 4 years. And before that, he got his master's in meteorology from Florida State. I'll pull up his screen or our slide so you can see. While at Florida State, he was a lab instructor for introductions to meteorology. And prior to getting his master's, he worked in the private sector. He has been involved with our local chapter for quite a number of years. Last year he was president-elect, and the year before he was secretary. Sid, why don't you go ahead and start your presentation. Let me let you share I'll stop sharing my screen so you can share yours.
Thank you, Steve. It's my privilege to talk to you all today about what we do at the National Weather Service and a few memorable weather events that I've worked over the last few years. The National Weather Service operates 24 hours a day, 365 days a year, including holidays, providing up to the minute forecasts and warnings to protect the lives and property of citizens across North and Central Georgia specifically. The mission of the National Weather Service is to provide the best possible climate forecast and severe weather warning products and services for the residents of North and Central Georgia. But aside from observations, forecasts, and warnings, we have so many other things that we do that we're going to talk about in this presentation. The National Weather Service is a federal government agency. We are part of the Department of Commerce under the National Oceanic and Atmospheric Administration. We have weather forecast offices, river forecast offices, and center weather service units. The National Weather Service operates 122 forecast offices in 6 regions. Each weather forecast office has a geographic area of responsibility, also known as a county warning area. Our office covers 96 counties, stretching from Georgia, Tennessee border to as far south as Americus and Vidalia. The CWSUs monitor and provide weather forecast and advisories to the nation's 21 air route traffic control centers. The nation's 21 CWSUs concentrate fully on aviation weather and ARTCC producing specialized tailored forecast and advisories for thunderstorms, turbulence, and precipitation affecting the national airspace. And circled here is the Atlanta CWSU, which covers the airspace over our area, and that's who we collaborate with when we do aviation forecasting. And then finally, the duties of the River Forecast Center are to provide river and flood forecasts and warnings for the protection of lives and property, and to provide basic hydraulic forecast information for the nation's environmental and economic well-being. Their duties are also precipitation analysis, headwater river modeling, and mainstream river forecasting. This is the area that covers our forecast area, with the exception of the far northwest corner is the Southeast River Forecast Center. And we actually share an office with those folks as well. Speaking a little more specifically about our forecast area, here's all the stuff that's covered by our WFO. We have 96 counties, which is the most in the NWS covered by that. 7.6 million people, including 7 airports that we cover with aviation forecasting. And we also have the 9th largest metro area with the Atlanta metro area, which has grown by over 1 million people since 2000. The Peachtree City, Atlanta office, or FFC staff, includes 16 meteorologists, many of whom have advanced degrees. So this down here on the bottom is all of us and the Southeastern River Forecast Center as well, when the NOAA administrator visited our office several months ago. We have management such as the meteorologist in charge, the warning coordination meteorologist, the science and operations officer, and then also the service hydrologist and aviation services meteorologist manage those specific sectors of our forecasting. We also have a data acquisition manager who's in charge of all of our observation systems, and 5 senior meteorologists, 11 meteorologists, and also staff that supports us every day, such as an administrative support assistant, electronic systems analysts, IT officers, and LTECs, along with some student volunteers that we have in the office as well. So we have a big, robust team here at the National Weather Service in Atlanta. Here's a look at our operations area of what it would look like on a pre-COVID-19 day, and what our setup looks like. So I'm going to go over briefly what each desk is doing. Dylan here is the public service desk. He's handling a lot of the correspondence to the public. He's doing data acquisition, quality control, and also taking phone calls, posting over social media, and then keeping all of those duties away from the forecast desk. Adam is on the long-term desk. He's doing the day 3 through 7 forecasts, day forecasts, along with any fire weather concerns, any backup radar that needs to be done, anything to help out the other forecast desks. Kyle is on the short-term and aviation desk, and he's doing the day 1 to 2 forecast and all the aviations. So that's for my money, that's one of the busiest desks you can be on at any time in operations. Ryan is on decision support services. He's communicating with partners such as emergency managers, getting correspondence to them in the case of severe weather. Dave and I both had our eyes on radar that day. A storm system was coming through, so the two of us were both interrogating radar. And then Laura was doing hydrology, and she's the service hydrologist, so that's her field of expertise, and she was issuing river flood warnings with heavy precipitation that fell that day. Now we'll talk about the specific duties that comes with the daily life as an NWS meteorologist. NWS operations start with data. And then what we do with that data to process it into information and get that information out to people who need it. So we have many different forms of data acquisition, including weather balloon releases, ASOS, co-op, and CoCoRaHS observations. We get data from local Mesonet and RAWS sites, and then also daily climate data. All of those are ways we get data, numbers and data that we work with to help turn that into forecast and communicable information. So the actual instrument that collects this data, the upper air data, is called a radiosonde, which the arrow is pointing to here, and it's attached to a weather balloon. And that is filled with hydrogen, which that's going to rise. Generally, it ends up about 25 to 30 kilometers up in the air before it bursts. And every second, the radiosonde measures temperature, moisture, wind speed and direction, and pressure. We have about 1,200 sites around the world that measure the atmosphere in this way. These balloons are released twice a day, every day. The data itself is also radioed back to a receiving unit by tracking the movement of the balloon and the instrument as it rises to the atmosphere. We can also use that to take wind speed and direction as well as it moves up. So this data is all sent to supercomputers in Washington, D.C. Calculations and observations all go into various weather forecast models. And this model data is what we calculate every day for our routine forecasting duties. We forecast out to 7 days. We have a few other duties in addition to the routine forecast. Aviation is something we do every day. We do aviation for 7 airports. We have fire weather. We do daily and site-specific forecasts for partners like the U.S. Forest Service. Severe radar and severe weather operations are always critical, as are tropical, winter weather, and river flood operations in the appropriate seasons. Aviation forecasting is performed by the short-term forecaster every day and involves the generation of terminal aerodrome forecasts, or TAFs, and they're coded for every 24 hours. Except for the Atlanta Hartsfield, which is for 30 hours, and we forecast wind speed, direction, visibility and obstructions, present weather, clouds, and ceiling heights. On a local level, we're responsible for 7 TAFs. All of them are issued every 6 hours, except for Hartsfield, which has to be amended every 2 hours. We have at least 1 meteorologist interrogating radar each day, perhaps more depending on the situation. And it has to be a bit flexible depending on the weather. So we have eyes on our radar at all times as needed. We interrogate KFFC, KJGX down at the Robins Air Force Base, Tattle at Hartsfield, and other surrounding radar from other offices. The NWS is the only weather agency that can issue official warnings. So any tornado, severe thunderstorm, flat flood and flash flood, and special weather statements, all those come from our office. We also, during severe weather, are going to be gathering storm reports and working on verification. We can gather these from a multitude of sources, such as from trained skywarn spotters, emergency managers, 911 call centers, broadcasters, public. We can get them over social media, et cetera, et cetera. We also conduct storm damage surveys after tornado events to determine the enhanced Fujita rating. This picture on the bottom is a damage survey we did a few years ago after January 22nd, 2017. And this car had been flipped into a double wide trailer. It was a high-end EF2. The trailer part took significant damage from that storm. We also do verification for tropical cyclones. We'll issue the post-tropical storm report, gathering local storm reports of damage during tropical events as well. We also do long fuse products by collaborating with other offices, offices such as the National Hurricane Center, the Storm Prediction Center, the Weather Prediction Center, and then our neighbors. And we issue long fuse watch and warning products over determined times and locations. So some examples, for example, these are hazards associated with Hurricane Michael. We have a hurricane watch, tropical storm warning, and flash flood watch all in effect at once for these areas in our CWA. Routine fire weather forecasts are usually issued and used by partners such as the U.S. Forest Service. They can be requested and filled via a spot forecast. They can be done for prescribed burns, wildfires, hazmat, or any other special events. Trained IMETs also can provide on-site support. For example, for a wildfire, an incidental meteorologist can be deployed to the site and provide on-site information to the people fighting the fire. Hydro operations are an important part of what our office does. Requires the collaborations with the forecast center, and we use river stage obs, RFC forecasts, unit hydrographs like on the right hand side of this image, and site-specific forecasts to create river flood warnings. As you can see on the left, this was a busy day on December 28th, 2018. We had a lot of spots in at least action level across our area, along with minor flood and moderate flood. That day we had over 24 hours, we had a big swath of 4 to 6 inches of rain, essentially going right up the I-85 corridor. At the bottom is Peachtree Creek in Fulton County. And this is another picture of what it looked like later that day. So that was a moderate flood in that area, and that was all because of that amount of rain during the winters in such a short amount of time with already saturated soils. An initiative we've been working towards in the last several years is trying to build what we call a weather-ready nation. The U.S. experiences multiple billion-dollar disasters each year. Here you can see the billion-dollar disasters so far for the year of 2020. We have a couple of them that have been prevalent across the Southeast, severe weather in February, May, and then the Easter Sunday tornado outbreak, just to name a few. And the reason we want to build a more resilient weather-ready nation is because weather challenges require good communication. And we have many challenges at our office year-round: rush hour precipitation and aviation. In the spring, we often see tornadoes and severe weather, along with flooding and fire weather during the burn season. Summertime pulse convection during the summer, flooding and fire weather, along with peak tropical season during the fall. And winter is when things get tricky as well. Low top, high shear supercell storms, snow and ice are always a challenge. And cold air damming into Atlanta, or sometimes no cold air damming when we have it forecast. We've been working to address that through public education, through better communication of our forecasts, and building relationships with people, with stakeholders such as emergency managers that use this information that we put out. So it's being done through consistent and transparent messaging, building relationships through events such as our integrated warning team, weekly and special weather briefings, on-site and remote support for high-impact weather events, and also high-volume public events such as the Super Bowl. We're active in sharing the latest forecast information on Facebook and Twitter, and we're always doing outreach events when available and when it's safe to do so, such as partner workshops, Skywarn storm spotter training, giving resources to all parts of the community, such as deaf and hard of hearing, awareness weeks, and EMAG meetings, and so many more. So just a few pictures. Here's our integrated warning team a couple of years ago. A talk we gave, we had an interpreter with our storm spotter resources, so now they can teach that class. This is one of our hazardous weather and flood preparedness courses for emergency management personnel. A few of our forecasters met and briefed the governor We do educational talks. Here's Lauren posing with Captain Planet. And then we also are active on pushing messaging out on social media, and then also do media workshops at local stations. The topic of a weather-ready nation ties well into the high-impact weather events I've worked over the last few years. So this particular picture is from damage after Hurricane Michael in west central Georgia, which will be one of the events we discuss. The first we'll look at is the December 8th through 9th, 2017 heavy snow event. One thing that stood out about this event was the unusual synoptic pattern in the southeastern US. Here's our 500 millibar heights and vorticity, and then our 1,000 to 500 millibar relative humidity. So stepping through this, the persistent long wave trough over the area supported deep southwesterly flow with subtropical moisture and embedded shortwave energy for nearly 24 hours. A series of waves ahead of the main trough helped organize banding of precipitation, and then those disturbances provided continuous focus for precipitation right within that southwesterly flow up in the northern part of Georgia. So what we saw was a very sharp gradient of snowfall through the metro Atlanta. That's often a forecast challenge for FFC. For our office, is that it usually seems like Atlanta is the delineation point between snow and rain. Up to 12 inches was measured in Cobb County, and then also nearly that much in some of the areas in the northeastern mountain, which is exceptionally rare. We had over 200,000 customers without power during that event. Here's a few pictures we got from reports over social media. One thing to note is all the snow and ice on the roadway in Hiram, Georgia, and then the impacts it had on the power poles and power lines, like in Powder Springs. Both of those are big infrastructure problems because Georgia, like much of the Southeast, is not as readily equipped to handle winter weather hazard as the northern states. So what does that mean for us? This table shows many of the impacts that we can face based on snow and ice. Just even retail trades, manufacturing, communications. Snow and ice affects all parts of our infrastructure in Georgia. We've had several tropical systems impact our forecast area over the years, including Matthew, Irma, Nate, and Alberto, and of course, Hurricane Michael. And Michael formed late on the 6th of October of 2018 and quickly moved north in the Gulf of Mexico. Warm sea surface temperature and favorable shear environments led to rapid intensification, and it was already a Category 1 by the morning of the 8th. And it made landfall. Here's a radar image nearing landfall. From the multi-radar, multi-sensor data on the 10th and as a Category 5 and moved northeastward inland. Now this illustrates the forward speed. So from 2030 Z to 3Z, it had already moved nearly into central Georgia from Florida. So the fast speed, forward speed, contributed to strong winds making it into Georgia because it didn't have too much time to weaken over land. So it was still a Category 3 entering Georgia, and this considering it was a Category 5 at landfall, the fourth ever in the US. So even on these winds, we had a 115 mile per hour gusts in southwestern Georgia. And even parts of our forecast area experienced Category 1 winds. An interesting image here is on you can see on the satellite imagery as it comes through, you can see the observations of the winds that it's taking, and then how there are no observations behind it, because all of the observations, all the ASOS stations were taken out by the winds as they moved onshore. Numerous structures were damaged along with trees and power lines down. Significant timber damage across portions of southwest Georgia. Due to the fast motion and dry soil, the flooding was limited. 3 confirmed tornadoes touched down in the outer rain bands, and the northeastern side of the system is generally most favored for the tornadoes. Tallahassee's forecast office wrote an excellent assessment as well for Hurricane Michael, and that can be seen at the link below. Last but not least is the Easter Sunday tornado outbreak. We had a strong negatively tilted trough swinging into the southeastern United States, along with deep moisture with southwesterly flow for it to work with. This also had a deepening occluded low pressure moving over the Great Lakes, dropping a cold front into the forecast area. But what was truly interesting was the shear ahead of it contributed to storm relative helicity values of up to 600 to 800 meters squared per second square over the northern parts of our state, which is exceptionally rare in a highly sheared environment. And with considering that, our surface cape for our instability was very, very high for that time of the year because of that persistent southwesterly flow. So we had all of the ingredients showing that we were going to have a significant tornado outbreak. The Storm Prediction Center highlighted a day 3 enhanced risk and upgraded to a moderate risk on day 1. A lot of the people in the office, we recognized that, and the messaging in advance of the system was critical. So we made it a point to talk about tornado sheltering best practices, sheltering guidelines, considering COVID-19, nighttime tornado threats. And then we made sure to say that we really were looking at a historic severe weather outbreak. And then the best ways to receive warnings and WIA alerts, and then emphasis on the threats. All of these things were informations we pushed out. Here's a quick look at some of the radar loop as it came through. You can see we have some, you can even see these notches within this broken line. And then the inflow notches behind it are good favored locations where we had strong winds and then tornadoes on those bookends of those lines. At 7:20, the first tornado watch was issued for Northwest Georgia. Another one went out from 11:45 p.m. until 7 a.m. We had warnings all across the area through the evening and overnight hours, and 21 confirmed tornadoes in north and central Georgia. Here's all the reports that we received from damage, including those tornadoes. These are some of the rotational couplets that we saw on radar as it was coming through. So this one here with a very pronounced debris ball was, this one was for, that one's for Upson County. The second one was damage from Monroe County, Georgia. And then the third one was for Catoosa County. These were all EF3s and caused significant structural damage. For Upson County, the house was actually lifted off its foundation and put into the middle of the road. So that concludes my talk. I'm going to hand it back over to Steve real quick so he can wrap things up.
Great. Thanks, Sid. That was really a great presentation. And for those that are still on the webinar, if you have any questions for Sid, please enter them in the chat. Great. So before we get into some questions, just want to remind everybody that this has been the 4th of our webinar series. We have 2 more planned over the rest of the summer. We have next week, Adam Baker, also from the forecast office in Peachtree City, will give his presentation. And then we have sometime in the near future, Rebecca Moulton from FEMA here in Atlanta will make a presentation as well.